looking at these functions here, these rational functions dividing two polynomials. What we looked at before is when you have a polynomial like this, what function is that going to behave the same as? 2x to the 5. What polynomial is this going to behave as? 3x to the, what is that, a second under there? Now, I can't put this, I can't say that this is equal to that, right? Because they're not equal to that. What I can say is I can say, no, you can say the limit of f of x. The limit of f of x as you approach plus or minus infinity. Should I pause again? I don't want to have to blame you at the end of the year if we're behind.
The calculus book, actually.
I don't want you to get caught up in what you write here. I want you to understand the concept. Here's this complicated function. But if we want to look at an end behavior model for that, you can kind of look at limits. Remember, we can't say f of x is equal to this function, but you can say it'll have the same limit as that. Or if I want to simplify it even more, once I look at end behavior models, what could I simplify this? This could be simplified. Yeah, 2x to the third over 3. 2/3 x to the third. So remember, we're not saying the functions are equal, but we're saying this function and the original function have the same behavior as you go to the left and the right. Or in other words, this is an end behavior model for f of x. And in other words, the reason is because it has the same limit as you approach positive or negative infinity. I'm just going to put same limits. The behavior as you go to right or left is the same. Okay? There isn't really anything to write other than if you want to support your idea. I mean, if somebody says, what's the end behavior model for that? You can probably pretty quickly say, well, on top here, the dominant term is going to be that one. In the denominator, the dominant term is that one, the highest degree. If I was tricky, I guess I'd write it like with not the highest term not written first, if you really wanted to know that. But that would catch you. It would catch me probably. Okay, now remember, you can't just say equals 2x to the third over 5x to the third because it's not true, right? But you can say the limit, right? Limit of f of x. I mean, the rest of them here pretty much, well, all this is looking for end behavior models and justifying them with limits. If you want an end behavior model for that, what's it going to be? You can find it right away without really doing anything. It's just going to be 2x to the third over 5x to the third, or 2/5. What does that mean graphically? It means, what does it mean? Because I think probably if I said what does a graph of that look like, you wouldn't know what the graph of that looks like. But now that you look at this, you still don't know what the graph's going to look like, but you know what's going to happen as you go to the right and the left. What's going to happen? The fact that this has a constant number as an end behavior model, what are you going to have as you go to the right and the left? Yeah, it's gonna just level off at 2/5. Whether it's from above or below, I don't know. But if you graph that big complicated function, it's going to level off. Maybe we'll pause. So that's neither of those, but it's similar to the one up above. You notice that as you go to the right, it's not leveling off at anything. The fact that the first one had this, it doesn't have a finite number. Remember that we said for it to have an asymptote, it has to have a finite number. Or in other words, the end behavior model has to be a fixed number like that. If you go back to this now and I change it to what it was supposed to be, which is 2x to the third, then it's leveling off at what? So it's, I mean, the resolution of the calculator is not that great, but it's pretty quickly leveling off. If we looked at the graph in the center more closely, it would look different. If you trace to the right, what's happening here? What's this value here? Well, it's going to take a long time, but what's going to happen eventually? Yeah, because yours is an 84, mine's an 83. We're not going to sit here and do this, but it's going to level off at that. If you make the window now bigger, if we go to 50 to, you're not going to see anything in the middle really, but it's not going to look like a whole lot in the middle, but it's hopefully going to level off where we want it to, right? Remember, you're kind of skipping the... I just saved myself some time there. See, it's 0.39. It's heading for 0.4, right? 2/5. An end behavior model. What you're saying is if this is an end behavior model, so that graph looked something like, I don't know, whatever was going on in the middle here, has an asymptote here or something. Doesn't look anything like that. It looks, I can't even remember now. Didn't it go like this or something? And this is going to then start to go up to there. All it's saying is if you draw y equals 2/5, those graphs are going to get closer and closer together. This is y equals 2/5, and then this is whatever that was, f of x here, this function. The graph's going to more closely resemble that line. Okay, and if you have a end behavior model that's just a number, a constant, it means it's a horizontal asymptote. There's some down below here that I would like you to look at really quickly. What all you have to do is let's just write a limit statement, and we know that this is the end behavior model. As you go now, notice that I put the same one twice. If you have rational functions like this, it's going to have the same end behavior model on the right and the left, because when you simplify this, you get the same thing either way, right? The one I gave you before was this one that we started last time and finished today. This one was one that had a different right and left end behavior model. These rational functions down here are going to have the same. So if you want to leave this out and just put plus or minus infinity here, you're welcome to do that. What is that going to be the same as here? You're looking at the dominating terms here. That's the same as the one above, right? Similar.
Exactly.
It's exactly the same. What is that going to be the same as? 2x to the third over 3, right? What's the limit going to be as you go to the right or the left here? No idea. One of these computers is making funny noises. Actually, I lied over here because it's going to be slightly different if we ask what the limit is. The limit as you approach infinity is going to be what? As x becomes infinity here, do you need the thinking person again? Yeah. You put infinity in there, can you imagine what it's going to be? 2 times infinity to the third? No, I don't want you to get caught up in all that. What am I supposed to write? I don't know. All you're doing here is you're saying if you want the limit of this big complicated function, if you think about its end behavior model, it's a lot easier to think about what the limit is. As x approaches infinity here, this is going to be infinity, right? I'm also challenged in drawing infinity signs for some strange reason. Why is that going to be infinity? What's it going to be over here on this side? This is as you go to negative infinity. It has that same limit. So this is going to be negative infinity because what you're thinking of is the end behavior model for this. This limit is going to be the same as limit as you approach negative infinity of 2x to the fifth over 3x to the second, or in other words, 2x cubed over 3. 2x cubed over 3. If the x is left on top, right, when you think about 2 times infinity to the third, or negative infinity to the third, this is going to be negative infinity. Whereas when these are the same, you think about what's going to happen there. And when the bottom one is bigger, think about what's going to happen. I'm going to pause this and conserve my any viewers at home. But so there you go. I did all the talking before I pressed start again. Yes?
How come the thinking face has no nose?
I don't know. You don't need a nose when you think.
Stop it.